Hey guys, so this first half of the week, we're gonna look at graphing more about graphing the exponential functions with transformations. So just as a review, you can tell if it's growth or decay based on what b is here. So if it's less than 1, it's going to show decay. Oops, that's a y. And then our y-intercept is our starting point, or a. So in this case, it would be the point 0, 2. And then since 2/5 is bigger than 1, this second equation shows growth. And the y-intercept would be the point 0, 0.35. So just to kind of review transformations and what we did before with them, looking at a quadratic, if you remember, the number with x moves it left or right, and it's the opposite. So plus 3 would go left 3, and minus 4 on the end goes up or down, and it's not backwards or anything, so it's down 4. So that would place our vertex at -3, -4, and then it's a parabola. So as far as domain, if you remember, it's how far left to how far right it goes, which in this case, it goes forever, so it's all real numbers. And the range, the lowest it goes, is -4. And since everything's above that, you would say y is greater than or equal to -4. So all of that is going to be really similar to what we do with exponential functions. So the transformations are still just going to be based on the, we're just going to go based off of these two numbers. So this plus 2 that's with the x moves it left or right, and it's the opposite of what makes sense. So plus 2 means that it went left 2, and this minus 1 moves it down 1. So to actually graph it, I'm going to suggest that you use GeoGebra, so I'm going to type in y equals 2, and then in parentheses put 1/2, and then it was to the x plus 2 power. And then if you hit the arrow button under the equal sign, that makes it come down out of the thing, and it was -1. -1. So that's what the function looks like. But if I want to get some actual points to plot, I'm going to get a table of values. And again, I'm going to go from -5 to 5. So I'm just going to plot the points that are not decimals and that will fit on my graph. So in this case, at -5, I have 15. So -5 was 15. -4 is 7. So plot that point. -3 is 3. -2 is 1, and 1 is 0. -2 is 1, and 1 is 0. So those are my points. But if you remember last week, I said that you're going to have to pay more attention to the asymptote. So with transformations, the asymptote moves. It's no longer on the x-axis. So this is my asymptote, this number. So at -1, I'm going to put a dotted line right there. And then I'm going to connect the dots and put arrows on it. So as far as domain and range goes, it's still, domain is still how far left to how far right. So the furthest left it goes is forever, and the furthest right it goes is forever. So since it has arrows on both sides, my domain is going to be all real numbers. For the range, that asymptote is my boundary. So whatever the asymptote is, that's where I'm going to put for my boundary for the range, and everything's above it. Now this time it does not get the or equal to sign under it. So up here we said y is greater than or equal to -4 because the vertex was a point, my boundary was a point. But this time it's a dotted line, so it's not actually included. Now since my b is less than 1, it is decay. That is still true, or you can look at your graph that it's going down from left to right. So that is how you graph with transformations, how you get all that information. Just as so here's another one. So again, for my transformations, this -1 is going to go right 1, and this +2 will take it up 2. And before I even get any dots, I can go ahead and put my asymptote at 2. So I'll just tell you right now, my domain is going to be all real numbers again, because all exponentials have a domain of all real numbers. My range is my asymptote. That's the boundary. So all my y's are going to be greater than 2. Since my b is bigger than 1, it is growth. So to figure out the points to plot, I'm going to go back to GeoGebra. I'm going to change this. It was 2, instead of 1/2, it was 2 times 3, so the x minus 1 plus 2. I'm going to hit enter. And back over to my table of values, I only have 2, maybe 3 points I can plot. So 1, 4, 2, 8, 1, 4, 2, 8, and then 3 was 20, which would be like up here. So then I'm going to just connect the dots without touching or crossing the asymptote. There you go. Just as review, writing equations. So A, remember, is your y-intercept. So in this case, it's 1. In this case, I go from 1 to 2 to 4 to 8. So I am multiplying by 2. So that is the equation 1 times 2 to the x. My domain will be all real numbers. And since I haven't transformed it, my asymptote is at 0, so it's just y is greater than 0 for the range. For an example with with decay, my y-intercept is 27. It's kind of hard to read those numbers, but it's going up by 3. So it's 27, and then it goes down to 9, and then 3, and then 1. So I'm dividing by 3, which is the same as multiplying by 1/3. So my equation is 27 times 1/3 to the x. Domain is all real numbers. Range is y is greater than 0. So there you go. That's all for the first half of the week. I'll see you guys in the live meets.